Hello, this is Miss Lefort, and we're going to learn about the unit circle today. So when we're looking at the unit circle, and I'm hoping you have your notes right there with the unit circle in front of you, notice that if we know the coordinate plane, we have our x and y axis here with our, we've got our x and y axis, see x is here, y is here, and with the multiples of 90, we always start at our x-axis here and going up around the circle. From 0, you get to 90 degrees. If you keep going, you get to 180, and then you get to 270, and then if you make the whole circle, it's at 360 degrees. So you should be familiar with that. As far as the 45 goes, notice every 45 degrees, we have from 0 to 45, 45 to 90, then to 135, 180, 225, 270, 315, 360. So basically, they're just going around and adding 45 degrees every single time, and it's still the same unit circle, okay, all the way around. So I'm going back to the page in front, and I am going to write in what these are in radians. So we've got 0, 180 is pi, way over here. 90 degrees would be halfway to pi, so that's 1/2 pi, or pi over 2. At the bottom, 270 degrees would be 1/2 pi, but we write it as 3 pi over 2, so it's 1/2, okay? So then when we're looking, and if we go all the way across, we get back to 2 pi. It's at 0 pi and 2 pi. So that's your radian measure. You need radian measure a lot in calculus. When we look at the 45s, notice there's 1, 2, 3, 4 parts to get to pi. So basically, this is 1/4 pi, or 1/4 of pi, which is pi over 4. This would be 2/4, which simplifies to 1/2. And then you got your 3/4 pi. And of course, the pi would be 4/4. Then you've got your 5/4, your 6/4, which of course simplifies to 3 pi over 2. Then you've got your 7/4, and of course 8/4, I'm writing it on the side there, is 2 pi. So notice all of them, if they're simplified, they're they're all there, they're just simplified. But you got to remember it goes into 4 equal parts. Now notice on this one, we've got multiples of 30 and multiples of 60. So you can kind of look at it in pieces. We're going to put it together here in just a minute. So notice, again, start at 0. Add 30, there's 30, then 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. So that's multiples of 30 around. So notice that there's 1, 2, 3, 4, 5, 6 equal parts on the top from 0 to 180 degrees. That's our pi. We're going to talk about that in just a second too when we label those on. Over here we have multiples of 60. So notice there's 1, 2, 3 parts there. And then 1, 2, 3 parts here. So what we're going to do is go back to the one on the other and put our radian measures on these, okay, before we put it all together. Okay, on the 30s, notice we have 1, 2, 3, 4, 5, 6 equal parts to pi. So that means this is 1/6 of the way, or pi over 6. Then we'd have 2, 6, but of course that simplifies to pi over 3. Then we've got 3, 6, but of course that simplifies to pi over 2, which we already knew what that one was because it doesn't change. Then this one would be 4, 6 of pi, which that simplifies to, look at me, I wrote a 5. It simplifies to 2 pi over 3. This one would be 5 pi over 6. And of course, this one would have been 6 pi over 6, but that goes to pi. Then you've got 7 pi over 6, 8 pi over 6. That one simplifies to, let's see, it goes to 4 pi over 3. All right, and this would have been 9 pi over 6, but that simplifies to 3 pi over 2. So you really don't have to be writing the unsimplified versions on here, but sometimes it helps in learning it as it goes around. Okay, 10 pi over 6, but that goes to 5 pi over 3. We got 11 pi over 6, and then here would have been 12 pi over 6, but of course that simplifies to 2 pi. So as you're going around, you start to recognize what they are. When you have the 60 degrees, notice this is 1, 2, 3 parts to pi. So this would be 1/3 pi, okay, 2/3, 3/3, then we have 4/3, and then we have 5/3, and 6/3, 6/3 here, which is 2 pi. Okay, back to the beginning. So if you recognize it, that all the 60 degrees reference angles have 3 on the bottom, all the 30s have a 6 on the bottom, and the 45s have a 4 on the bottom. So if we put it all in the same one, okay, so here, and you've got your unit circle, you can just start filling out what you know, because you're going to need to fill all this out in radians also, because I'm expecting you know it in radians. This would be 0, why is my pen not there? There we go. Okay, this is 0 radians. This would be pi over 6, pi over 4, pi over 3, pi over 2. Now from there, when I go around, I like to do the matching ones at the same time. Like that's pi over 3, so this is 2 pi over 3. Then this one down here would be 4 pi over 3, because that's pi, which would have been 3 pi over 3. And then this one would have been 5 pi, or would have been, is pi over 3. And then 6 pi over 3, which is 2 pi. So then I'm going to do the 4s. We have pi over 4. The next one was here, okay, the 4s. I'm going to go ahead and mark them. That's the one, the 5s. Remember, see how they all end in 5? Pi over 4, this would be 3 pi over 4, 5 pi over 4, and 7 pi over 4. It's the ones that don't simplify. Oh, we forgot this one. This was 3 pi over 2. Put it there. All right, so now I need my 60-degree ones. Well, not 60-degree ones, my pi over 6s. There's 1, there's 2, there's 3, there's 4. The same distance everywhere, okay? Those are reference angles, which we're going to get to. So that would be pi over 6. This one way over here is 5 pi over 6, 7 pi over 6, and 11 pi over 6. So that's how they go. So notice they match. All of them are reference angles that are the same distances away. I don't know if you noticed that on those other ones, but that's important to see because that comes in handy. So when we look at a 30, 60, 90 triangle in the unit circle, and we studied the 30, 60, 90, or you did in geometry, and we used it in several things in trig already. But notice if we know the 30-degree angle, so see this 30-degree angle right here, if our radius is 1 and we use the special triangle and figure it out, then our x value becomes square root of 3 over 2, and our y value is 1/2. So you might want to go ahead and write that in on your 30-degree angle on that unit circle. When you get to the 60-degree one, okay, see that's the one that's taller, that one, the x is actually shorter now than it was on the other side. See how the x piece is shorter, this piece is shorter, so it's the 1/2. Where the y, this one's taller, so the y has to be bigger. And square root of 3 is bigger than square root of 1, so that's how I can tell. And it's the same thing, so notice this ordered pair for the 30 and the ordered pair for the 60 is very, very similar. It's the same numbers, just in a different place. So you need to remember which one is which. So fill that out on your unit circle. Now on the 45, 45, 90, if we put it in the unit circle and use our special triangle to figure it out, then this x becomes square root of 2 over 2, y becomes square root of 2 over 2, and of course my hypotenuse here is 1, that's why the radius is 1 in a unit circle, that's why they call it a unit circle. So this one's easy, it's the pi over 4s, okay, anything with a 4 on the bottom has this same ordered pair, so that's kind of nice, so you need to to write that one down also. Now, when we put it all together, your quadrant 1 of the unit circle looks like this. You need to be familiar with this unit circle, okay? You need to, if you just know the first quadrant, you can map out the rest of it easily, just knowing the signs of the X's and Y's in the quadrant plane. It's really not a big deal, in the coordinate plane, I mean. It's not a big deal. You'll know what they are. So you need to memorize this whole part, okay? You should know this. Figure out a way to learn it and just know it. Now, when we're working on the 30-degree angles, notice how we have all 4 of them here. These are called reference angles, and we're going to talk more about this in class. But basically, that first 30-degree angle, which is pi over 6, remember, has this ordered pair. So every one that is the same distance away from the nearest x-axis has the same ordered pair. The only difference is the sign based on what quadrant you're in. So notice how over here in quadrant 2, x is negative. So it's the same ordered pair as the 30-degree reference angle on that side, only the x value is negative. So it's really not tough to figure that part out. Quadrant 3, both x and y are negative, same ordered pair because it's 30 degrees down instead of 30 degrees up here, right? You see? So this one is the same. And then this one in the 4th quadrant is 30 degrees down, so no 30 degrees. This is our reference angle. It's got to be the nearest x-axis. They all have the same ordered pair. So this has a 6 on the bottom in radians, 6 on the bottom, 6 on the bottom, 6 on the bottom. So I kind of like using the radians because it's kind of easy to remember where they fall. Now, when I look at the 45-degree angles, notice it's 45 up, 45 down, 45 up, 45 down. It's the reference angles. It's the angle to the nearest x-axis. Okay, so they have the same exact ordered pair. So this is the easy one. This one has a 4 on the bottom. This is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So every one in radians that has a 4 on the bottom, I know it's the square root of 2 bit, right, on all of it. I just got to decide what sign would x and y be based on the quadrant that it falls in. So just pay attention on those and go ahead and fill those out in your chart because you're definitely going to need them. And now when we go to the 60-degree angles, they all have it. You see how this one has 60 degrees up, 60 degrees down, 60 degrees up, 60 degrees down. You need to, these are all the reference angles. Every one that's 60 degrees away from that the nearest x-axis has this same ordered pair, just the signs are different based on the x and y and what quadrant it's in. So you need to know all of that. So pause the video if you need to and jot it down. Now on this screen, we have all of it put together. The only thing we don't have on here is your radian measurements, okay? Everything's in degrees here. So let's see if we can go ahead and write this in. That way you have everything together. So we have 0. This one is pi over 3. This one's, I just wrote that wrong. That's not pi over 3. Now is it? I'm glad you caught me there. Okay, that's pi over 6. Because remember, 180 is about, pi is the same thing as 180. It's a different measurement, but they are the same. They're equivalent. So this is like 180 divided by 6 is 30. Okay, so this would be pi over 4. This one would be pi over 3. This one is pi over 2. 2 pi over 3. This one is 3 pi over 4. 5 pi over 6, and of course pi. And then we'll keep going all the way around. Yes, you need to know all these, so pay attention. 7 pi over 6. This one would be 5 pi over 4. 4 pi over 3. This one's 3 pi over 2. Let's keep going here. 5 pi over 3. 7 pi over 4. And 11 pi over 6, and of course it ends at 2 pi. So put that in there. You need to know all of that and be able to use it appropriately. Now on this portion, you need to make sure you remember SOHCAHTOA, and I know you do already, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So all that's hugely important. The Pythagorean identities, that stems from the Pythagorean theorem, basically, where you have a squared plus b squared equals c squared. So you need to be familiar with these. Now the biggest one you need to know is this one right here, the first one, cosine squared plus sine squared is 1, because 1 squared, it would be the radius, and 1 squared is 1. These other two you can find by dividing this first one by either cosine on all terms, cosine squared, or sine squared. Okay, and that'll walk you right to these, which I'll show you in class if you have questions about it. But at a minimum, you need to have this memorized, and you would need to have this one memorized. Okay, you need to just know it. Now, when we use our unit circle, one of the great things about the unit circle is because if the radius is 1, then we can easily determine the trig functions of angles that are in that unit circle. You need to know that sine of theta is y, the y value. That's why we want those ordered pairs from that unit circle. So sine is y, cosine is x. Okay, so you just need to know that. Tangent, we know, is y over x because it's sine over cosine. So that is hugely important. And then you need to be familiar with these reciprocal ones. Cosecant is the reciprocal of sine, secant is reciprocal of cosine, and cotangent is reciprocal of tangent. If you get 0 on the bottom, like here, then we would say it doesn't exist, and that happens. Okay, you can have D and E on those. If, however, we're solving for a trig function and we have a triangle, we have the information for a triangle, but we don't have it on the unit circle. Like it fits on the coordinate plane, but the radius isn't 1. So then we have to consider that radius. So here's where we got to know all of these, okay? This is the same thing. This is SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent's opposite over adjacent. So you know this already. It's just that if it's on the unit circle, the hypotenuse is 1, which is really nice. But here we got to put the r. So like, let's say the hypotenuse was 5, okay? We have to put 5 where the r is. So that's just going to change our calculation somewhat. We'll have some of those. So you need to know, if r is 1, if it's on the unit circle or not. So all that is very, very important. Okay, so now that we've gotten all this taken care of, I want you to use that unit circle. I want you to learn that unit circle, memorize it, and then we're going to use that to do our notes for 7-5.